In problem number 46, we have tatami mats used as a floor covering in Japan. One possible layout uses 4 identical rectangular mats. So I'm going to label these as R1, R2, R3, and R4. These 4 identical rectangular mats and 1 square mat. We'll just call that S. As shown, we know that the area of the square mat is half the area of one of the rectangular mats. We also see here that the total area is 81 square feet. So we want to write and solve an equation to find the area of one rectangular mat. Well, one thing that we know here is that the total area is equal to the sum of the individual areas. And we know from the problem that the total area is 81 square feet. We also know that we have 4 rectangular mats, all of equal area, and we'll represent those by the capital letter R. So we have 4 times the area of each individual rectangular mat, and then we have 1 square mat, and we'll represent its area by the letter S. Now, if we had 2 variables here, there's no way for us to solve this with just one equation. However, we are given the piece of information that the area of the square mat is half the area of one of the rectangular mats. So we can modify our equation to say something like 81 is equal to 4R plus, we can either use 1/2 or use 0.5R. Now we know that we can combine those like terms, and 81 is equal to 4.5. 4.5 times the area of one of the rectangular mats. That's what that means. 81, the total area, is equal to 4.5 times the area of each rectangular mat. Now we know how to solve this. We're simply going to divide both sides by 4.5. And therefore R is equal to 18 square feet. So the area of one of the rectangular mats is going to be 18, and we can add those up. 18, 18, that's 36. Another 18 is 54. Another 18 is 72. And we know that the square mat is half of that, so that would have to be 9. 72 and 9 is equal to 81. Alright, so there you go. We've solved for the area of one of the rectangular mats. Now there is another way to look at this particular problem, and that is to say that the length, we're told in part B, the length of the rectangular mat is twice its width. So I'm going to erase some of the stuff on our diagram here. We'll just use a different color instead. So if I know that the length is twice the width for one rectangular mat, that would mean we would have something like this. There would be 2 W's for each length. And that tells us that we really have this 3 W's on each side, and we go around and write the rest of them. 2 W's on the length, 1 on the width. 2 W's on the length and 1 on the width. So that means that as a square we have 3W times 3W, and that has to equal a total of 81 square feet. So that would be 3W. This is an important point here. Let me take a step back so I don't go too fast. We remember that multiplication is commutative. So that means I can change the order. I have 3 times W times 3 times W. I can change the order of the factors so that it looks like this. 3 times 3 times W, which we know is 9W squared, is 81. We can divide that by both sides by 9, and we know that a square W, which really is the area of one square mat, right? A square mat has an area of 9 feet squared. And so what number squared is equal to 9? So W would have to equal 3 feet. And if W is equal to 3 feet, we know that the dimensions of one of the rectangular mats then is 3 feet for its width and 6 feet for its length. And so we would end up with the dimensions 3 by 6, 3 feet by 6 feet for the dimensions of one rectangular mat. We'll stop this one here.